Hi everyone, let's get started with today's notes on exponential transformations. So I've gone ahead and filled in the information that we need right above the top section, and I'm just going to review that. So as we're talking about transformations, we're still talking about that parent function just like we worked with yesterday. And if you were absent yesterday, please go back and complete those notes before you move on to this one. So once we have the parent function, which in this case would be b to the x power, okay, we have to make note that there's a couple other things that we're looking at. We're going to be looking at an a value. We're going to be looking at the h value and the k value. That's what's going to get our parent function to change. Okay? So our h value that is up in the exponent with x, that there is going to be a horizontal shift. So that will do opposite of what we think. So if h is a positive number, it is going to move to the left. And if h is a negative number, then the graph will transform to the right. The next variable that we're going to be looking at is k. K is a vertical shift or vertical transformation, which makes the graph move up and down. Horizontal makes it move left and right. If h is positive, the graph will shift up. If h is negative, the graph will shift down. Okay. If a is a negative value, then the function is going to be reflected across the x-axis. So what that means is that instead of being above the horizontal asymptote, it is going to, above the horizontal, above the x-axis, it's going to be below the x-axis. Okay. All right, and then if a is greater than 1, it is going to have a stretch, which means it is going to seem more thin. And if it is between 0 and 1, like 1/2 or 1/4, but never a negative number on that one, well, it could be negative, but I'm just saying a itself will be a fraction, then it's going to be a vertical shrink. Okay, so let's look at some of those. So the first part, what we are going to do is identify key features just given the equation. So we're not graphing on these first ones. So the parent function on this one, let me pick up a different color here. The parent function on this one is whatever the base is to the exponent power. So my parent function here is 3 to the x. This one here is going to be a growth because the b value is greater than 1. That is what we talked about yesterday. If it's greater than 1, it's a growth. If it's less than 1, it is a decay. Right? So that means if we were graphing this, it would look something like that. Okay. The a value in this case, well, if 3 is the b value, a would be out front. And there isn't a specific one listed, so that means that our a value is 1. The b value in this case is 3. That's the number that would make this geometric. And then we have h. H is if there was something up here like plus h or minus h, that's what we would be looking at. Okay? So there is no h value in this case. So I'm going to put plus 0, or you could write out 1 does not exist. Okay, so to me it's just easier to write plus 0. There is no change. The k value on this is plus 5. Okay. Then I'm going to go through and just make notes. So since a is 1, there is going to be no stretch or shrink. And b is the base. H is no horizontal shift because it does not move left or right. And there is a vertical shift. It's positive 5, so it will shift vertically 5 units. So that is what we are doing on these. We are describing what those transformations are. All right, so let me go over to example number 2. So on example number 2, the parent function on this one is going to be 1/4 to the x power. One-fourth is less than 1, so it's going to be a decay. So if we were graphing it, it would look something along those lines. A in this case is 2. B is 1/4. H. So I want to see if there's anything up in the exponent with x, and there is. It's -1. So the h value is -1. And there is no k value. There's nothing at the end of that information, like no adding 5 over here or subtracting 5. So we have no h value. Again, you can put does not exist, like DNE, or you could put +0. So it doesn't change from where it's starting at. All right, so on this one, there is going to be a vertical stretch since it's greater than 1. Vertical stretch of 2. The base is 1/4. -1 is it shifts horizontally. And that is going to be 1 unit. And we have to pay attention that this one does the opposite. So since it's a -1, I'm going to scroll back to the top here. Okay. Since it is a -1, it is going to shift to the right. Okay. So it is going to go right. Don't have to worry about the vertical shift because there is none on this one. All right, so let's go to number 3. Our parent function is 4/3 to the x. 4/3 is greater than 1, so it's going to be a growth. The a value on this one, this is actually a -1 right there. So that's going to be -1. B value is 4/3. H is +2. And K is +7. When I have a negative value, that means it's going to reflect over the x-axis. Okay? So if A is negative, the function is reflected across the x-axis. So anytime you see a negative out front, I'm going to go ahead and write reflects across x-axis. There is no stretch or shrink because 1 does not change that. However, it's pretty important that I pay attention to that negative. 4/3, that would be our base. 2 is going to be a vertical shift or a vertical translation. Opposite of what we think, so left 2 units. And then we have +7, which is I need to correct that, guys. This isn't a vertical shift. This one is a horizontal shift. Okay, so let me put that in a different color to make sure you catch that. That was my mistake. That one's a horizontal shift. All right, so then +7, K value, that's the vertical shift. And that one is up 7 units. Okay. All right, I am going to go ahead and stop this video here, and then I'll go on to the second piece. I want you guys to complete this one on your own, describing those transformations.